Okay, so in this video we're going to look at a couple of examples of graphing lemniscates. And lemniscates, these are going to have the form r equals a plus b sine theta, or r equals a plus b cosine theta. And off to the right here we have a couple of general curves. They don't have to look like this. In fact, uh, depending on if we're looking at sine or cosine, we may have these curves being rotated, right? So just depends on if, like I said, if we have sine or cosine. All right, so but the general shape will look something like what I have written here. Okay, so let's look at our first example. Okay, and let's suppose we are given the equation r equals 4 plus 2 cosine theta. All right, so in terms of our property, here's A, and this is B, right? And so if I'm comparing it to one of these over here, it seems as though it's going to be where A is greater than B, right? So it's going to be this case here. Okay, so that case. And so we expect to have a dimpled lemicon. So what's not going to happen, you see here, this little point here does not actually hit the pole here. So it won't hit the pole at that point. So we'll start by first graphing y equals 4 plus 2 cosine x. All right. And so let's draw on our axis. So here's our graph of y equals 4 plus 2 cosine x. And I also went ahead and sketched in the polar coordinate system as well. And I went all the way out to 6 because the biggest that r will get is 6, as we can see here from the graph of y equals 4 plus 2 cosine x. All right, so now we've seen a couple of examples of graphing polar equations, so we know that we're going to start at the angle 0. So here is my angle 0. And when the angle is 0, r is equal to 6, as we can see right here. So that means that on the polar axis, we're going to start here at 6. Okay. And all right, so then the next angle I need to consider is pi over 2, right? So let's draw in pi. So pi over 2 would correspond to this right here, right? So here's pi over 2 at the top. And I want to know, as the angle goes from 0 to pi over 2, how are the r's changing? Well, the r's are going from 6 down to 4. Okay. And so at pi over 2, r is equal to 4. So let's say let's see, 1, 2, 3, 4, right about there. Okay. And r is going to decrease to that. So from 6 to 4, way down here like that. Okay. So next we need to consider pi over 2 to pi. So that's going to be from here to here. And then, so how is that changing? Well, I can see that the r's here at pi over 2, it's at 4. They decrease all the way down to 2 as we get to pi. So if I sketch in pi, which corresponds to this line here, I know it's at pi, it's at 2, so 1, 2, draw on that point. And then r is going to start from pi. As we go from pi over 2 to pi, it's going to decrease down to 2. So from 4 to 2. So we get that. Okay. Now, as we go from pi over 2 to 3 pi over 2, all right, the angles, the r's go from what? Well, they go from 2 back up to 4. So, well, here's 3 pi over 2. It's already sketched in here. And I know that this increases as at 3 pi over 2, it's at 4, so let me sketch that in first. So 1, 2, 3, 4, so right here's 4. And r increases out to that. So you have something like this. Okay, and then the last piece is going to be from 3 pi over 2 to 2 pi. So from 3 pi to 2 pi, we're going to go from 4 back out to 6. So it's going to be right back here at the beginning. Okay, and so this is what we call a dimpled, or we said a dimpled lemicon. And the dimple is going to occur right here. So doesn't look like much, but that's what it just means. Just a little bit of a dimple there. And then we come back out of it. Right? And once again, mine's not to scale. But that's what we have here. Okay, so let's look at another problem. Okay, so this next problem is going to be r equals 1 plus 2 sine theta. And so here we see that A is now less than B. And so the case we're going to have here is a lemicon with an inner loop. Right. Now, this one's a little bit more, we have a little bit more work to do here, because notice that we have these two x-intercepts, and these actually are very important to us because we need to know when we actually cross the x-axis, because we need to know the point where r changes from positive to negative. So before these 2 points, right, so when we have a 0, before it's positive, then after it's negative, and over here, for this one, it goes from positive to negative. All right, so it's just nice to know when r changes sign. Okay, so we need to figure out those points. Let's go ahead and do that, because we're going to need to know it anyway. And so it's just like finding an x-intercept. And so the equation here of this is y equals 1 plus 2 sine x, right? And the x-intercepts occur when y is equal to 0. So for the x-intercept, we're going to let y equal 0. And so we have 0 is equal to 1 plus 2 sine x. And so that's when sine x is equal to negative 1/2. And this is when x is equal to, now we're looking just between 0 and 2 pi. So when is x equal to negative 1/2? Well, it's negative 1/2 when we're in quadrant 3, and that's for 7 pi over 6. And in quadrant 4, 11 pi over 6. Okay. So these 2 points here, this is 7 pi over 6, and this tick mark here, that's going to be 11 pi over 6. Okay. Other than that, we just graph the same way we've been graphing. Okay, so let's start for the angle equals 0. So when theta is equal to 0, right, so now we're looking at theta equal to 0, r equals 1. So we're going to start right here. Okay. Our next point of interest is pi over 2. So pi over 2 is going to be this line right here. Okay. And, well, what happens? Well, it says that as theta goes from 0 to pi over 2, r goes from 1 to 3. So 1, 2, 3 here at pi over 2. Okay. And we go from 1 to 2. So we go out, or 1 to 3. So we have that. Okay. Now we are interested in pi over 2 to pi. So pi is, let's say, right about here. So that would be this line here. And what happens? Well, we're going to go from 3 back down to 1. So at pi, it's at 1, so we go from 3 back down to 1, like that. Okay. All right, now I want to go from pi to 7 pi over 6. So 7 pi over 6 is going to be, let's say, is right here. Okay, so let's say that's 7 pi over 6. All right. Well, what happens? Well, it says that as we go from pi to 7 pi over 6, r goes from 1 down to 0. So when we, at 7 pi over 6, we're going to be at the pole again. So we're going to start at pi, which is that 1, and we're going to decrease down to 0. Okay, so we get that. All right, now next we want to look at what happens as we go from 7 pi over 6 to 3 pi over 2. So all of this stuff that's in here, well, all the r's are negative. So what ends up happening is, first, I should probably look at the extension. So let me draw on the extension of 7 pi over 6. Okay. And now all the stuff that would be here now gets sent up here. All right. And what happens? Well, we're going to go from 0 out to negative 1. Now, so at 3 pi over 2, it's at negative 1. Now, if this is 3 pi over 2, then positive 1 would be right here. Negative 1 is going to be right here. And what does it say? Well, it says that from 7 pi over 6 to 3 pi over 2, we go from 0 out to 2. So we're going to start from the pole and increase out towards that. Okay. All right. Next, 3 pi over 2 to 11 pi over 6. Well, 11 pi over 6 is like right here. Okay, so this is 11 pi over 6. Now, since all the r's are negative, still between 3 pi over 2 and negative pi over 6, I'm going to sketch in the extension of 11 pi over 6. And now all the angles that would be here are now up here. And those are supposed to go from 1 back down to 0. So starting from here, from this one, we're going to go back down to 0, like that. Okay. And so see, there's that inner loop that we expected. Okay. Looks like we're almost finished. And now from 11 pi over 6 to 2 pi, all the r's are positive. So now we're looking at all the stuff in here, and those increase from 0 to 1. So we're going to go back out to 1. And there it is. Okay. So that's our lemicon with an inner loop.